Hello and welcome. Today I'm excited to present about HoneyPLC, a next generation honeypot for industrial control systems. Originally introduced at paper CCS 2020. My name is Simha Himakuntala and this presentation is for the CS 6263 EC 8813 course of Cyber Physical Systems. This project explores how high fidelity deception mechanisms in industrial control systems can change the future of cyber defense. Introduction about ICS and PLC threats. Industrial control systems, these are like power utilities, water, energy, and transportation. These are foundational services. PLCs, called as a programmable logic controllers, are the core of industrial control systems. They receive sensor inputs and driving physical actuators, pumps, motors, valves. Now consider this. If an attacker hijacks a PLC, they can tamper with real-world processes. That's exactly what happened with Stuxnet. The malware reprogrammed centrifuge speeds in Iran's nuclear facility. Ukraine 2015. Attackers disabled substations, causing a blackout for 225,000 people. These incidents showed us why industrial control system cyber attacks can be catastrophic and why understanding adversary behavior is crucial. Why honeypots for industrial control system? Honeypots are fake but convincing systems that lure attackers. For industrial control system, honeypots serve a dual purpose. They deceive attackers into revealing techniques. They collect artifacts, including malware and payloads, especially in industrial control system where real environments are fragile and cannot be risked. Honeypots offer a safe and ethical way to capture real-world adversary behavior. Let's look at current industrial control system honeypots like cornpot or gaspot. Most suffer from three major issues. Low interaction, simple emulations are easy to detect, limited protocol support, only basic Modbus or S7 communications, often partially implemented, no malware capture. They log traffic but don't collect uploaded logic or binaries. That means attackers can quickly identify and avoid these honeypots, or worse, feed them misinformation. HoneyPLC contributions. HoneyPLC solves these challenges head on. It's a high interaction honeypot that simulates real PLCs. It supports vendors like Siemens, ABB, Allen Bradley. It simulates protocols like S7 communications, SNMP, TCP/IP, HTTP, and it does something no other honeypot does. It captures uploaded ladder logic for forensic analysis. Honey PLC architecture overview. Let's break this down. PLC profile repository, where stores simulation templates for different PLC models. Personality engine uses Honeyed to simulate TCP/IP behavior, tricking tools like Nmap. Network services implements services like S7 communications, SNMP, HTTP for full protocol emulation. Interaction logger logs attacker IPs, timestamps, and injected code. Each of these modules plays a vital role in fooling attackers and capturing their payloads. Let's consider use case scenario. Here is a walkthrough. An attacker uses Nmap. Honey PLC replies like a real PLC. They scan for memory blocks using S7 communications. They inject a malicious ladder logic payload using PLC inject. Honey PLC logs the attacker's IP, the memory blocks accessed, and captures the payload. This interaction mimics real-world intrusions and produces actionable threat data. Let's discuss about PLC Profiler tool. To simulate diverse PLCs, HoneyPLC needs their profile. This includes SNMP MIBS. It's a management information base, structured database of device attributes exposed via SNMP. PLC exposes system IDs, firmware versions, and even uptime here. We get HoneyPLC uses we get to recursively download the PLC's embedded web pages, HTML, CSS, and images used in configuration portals. This way, attackers see a full authentic interface, one more way to convince them they are targeting a real PLC. Let's discuss about protocol simulation modules. Realism is critical. TCP/IP. HoneyPLC uses honeyed and reverse engineered Nmap fingerprints to simulate OS level quicks. S7 communications, it's going to build using SNAP 7 in C++, fully supports memory block interaction. SNMP uses SNMP SIM to reply to SNMP walks with billable data. HTTP uses light TPD serves as a cloned web interfaces from the real PLCs. The end result, Honey PLC is nearly indistinguishable from real industrial control system endpoint. Let's go through ladder logic capture. Now this is one of Honey PLC's standout features. It captures any ladder logic code injected by attackers, whether via Step 7 Manager or tools like PLC Inject. This captured code is saved on disk with a timestamp. Why is this important? Ladder logic is the control language of the PLCs. Capturing it allows security teams to reverse engineer attacker intent. You can extract control behavior, logic bombs, or safety overrides from malicious payloads. This is a game changer for industrial malware analysis. Let's see interaction logging capabilities. What good is deception without data? Honey PLC logs everything. IP addresses of attackers, timestamps of every S7 communications, SNMP or HTTP interaction, memory block access attempts, HTTP login forms, and SNMP GET requests. This log data can be sent to SIEM for correlation and it is invaluable for threat hunting in industrial control systems environments. Let's see evaluation questions. The researchers focused on answering three critical questions. Can Honey PLC support diverse real-world PLCs? Can it maintain covert operation and fool sophisticated reconnaissance tools? Can it capture malicious ladder logic for post-attack analysis? Let's walk through the experiments and see how Honey PLC performs. Let's look into experimental setup summary. To evaluate Honey PLC, the team used a comprehensive setup. Real Siemens PLCs of models like S7300, S71200, S71500, and in Allen Bradley Micrologic's 1100 versions and ABB PM554 versions. They created PLC profiles using the Profiler tool, deployed instances on AWS to expose them to the internet. They tested against Nmap, PLC scan, Shodan, and Step 7. This setup mimicked real-world exposure scenarios. Let's look into results of Nmap and PLC scan. In deception, the first test is, can you fool scanners? Honey PLC profiles achieved greater than 90% confidence from Nmap in OS detection. In many cases, the scans could not distinguish Honey PLC from real Siemens PLCs. PLC scan, designed specifically to fingerprint PLCs, correctly identified the simulated devices. This proves Honey PLC passes the first test of plausibility. Let's look into Shodan Honey Score. Shodan is a global scanner used to find exposed industrial control system devices. It uses a machine learning based scoring system called HoneyScore to flag honeypots. HoneyPLC got 0 HoneyScore for the S7300 profile, indicating Shodan believed it to be a real. By contrast, Conpot and Gaspard scored very high. Even that is very fake. This proves that HoneyPLC can stand its ground against even Shodan level detection. Let's discuss about results of Siemens Step 7 compatibility. Step 7 Manager is the actual engineering software used by Siemens to configure PLCs. Most honeypots crash when connected with Step 7. HoneyPLC is different. It allows upload download of memory blocks. It returns valid metadata like CPU serials and firmware. It even simulates errors like wrong password just like a real PLC would. This level of compatibility is crucial to collect actual attacker payloads. Let's see internet attacker interactions. Now the big question is, do attackers fall for it in the wild? Yes, over 5 months, HoneyPLC recorded over 5 gigabytes of real world traffic from more than 25 countries. Repeated HTTP logins, SNMP GET requests, S7 communication connections attempting memory reads and writes. This confirms HoneyPLC's ability to engage real adversaries. Let's see ladder logic injection results. Using tools like PLC Inject and Step 7 Manager, the researchers uploaded sample ladder logic to HoneyPLC. HoneyPLC captured and saved those payloads exactly as received, proving its malware collection capability. Competing honeypots either failed to capture anything or crashed during the injection process. This is a critical for cyber defense in industrial control systems, analyzing what an attacker wanted the PLC to do. Let's look into comparison with existing honeypots. Let's put things into perspective. Honey PLC is the only honeypot that supports multiple PLC vendors like Siemens, ABB, Allen Bradley. Realistic protocol simulations with S7 communications, SNMP, HTTP, ladder logic capture, covert operations validated by Shodan, Nmap, and PLC scan. It's not just a honeypot, it's a forensic platform for industrial control system cyber research. Let's see future industrial control system honeypot enhancements. Looking ahead, Honey PLC can be improved even further, adding support for more protocols like Modbus TCP, Ethernet IP, OPC integrate with SIEMs and OT SOCs for real-time alerting, adding AML analysis to automatically classify ladder logic payloads. These enhancements can make Honey PLC a core tool for industrial control systems red teaming and blue teaming exercises. Let's look into conclusion and takeaways. To wrap up, Honey PLC advances the state of industrial control system honeypots. It's a realistic, stealthy, and operationally useful. It supports real-world device simulation and captures attacker behavior. For researchers, security teams, and critical infrastructure defenders, Honey PLC is a powerful open source tool for threat analysis and deceptions-based security, and especially valuable in critical infrastructures like oil and gas, water, and power. It brings us closer understanding. Thank you for your attention. If you have questions or want to explore Honey PLC further, feel free to reach out through our ED discussions. Stay secure